So here we have another example. A heavy uniform metal beam AB of mass 500 kg suspended at its ends. The beam carries a mass of 3000 kg at a distance of 1.5 meter from the end A. The beam is 4 meter long. Determine the thrust on the supports A and B. So you have a beam. The beam has a mass of 500 kg and is suspended at its ends. The beam carries a mass of 3000 kg at a distance of 1.5 meter from the end A. The beam has a length of 4 meter. So you are being asked to find the thrust on supports A and B. So solution: you have a beam A, B. So this is point A and this is point B. The beam has a mass of 500 kg. So we assume this is the midpoint. So here is where the mass of the beam is located, which is 500 kg. And it is suspended at its ends. So the beam is suspended here and here. So we assume this point A has a thrust X and the point B has a thrust Y. The beam carries a mass of 3000 kg at a distance 1.5 meter from end A. The beam is 4 meter long. The length of the beam is 4 meter. So it is 4 meter long. The beam is 4 meter long. So it carries a mass of 3000 kg from point a distance of 1.5 from end A. So we assume this is 1.5 meter. So here we have 3000 kg. So you have been asked to find the thrust at point A and point B. So first of all, we have to change the masses into weight. So first, the weight of the beam. Weight of beam. This will be equal to 500 kg times 10 Newton per kilogram. So here you get 5000 Newton. This is the weight of the beam. And the weight of the mass suspended. Weight of mass. The weight of mass will be equal to 3000 kg times 10 Newton per kilogram. So here we get 30,000 Newton. This is the weight suspended. So we take moment about A. We take moment about A. Taking moment about A. When we take moment about A, it means all the distance should be measured from point A. So from the principle of moment, clockwise moments equals to anti-clockwise moments. Clockwise moment equals to anti-clockwise moment. Anti-clockwise moments equals to anti-clockwise moments. So from our diagram here, this weight here, 5,000 Newton and 30,000 Newton, will give a clockwise moment. Because we have taken moment about A, so the thrust at point B here will give anti-clockwise moment. So the clockwise moment, the total of clockwise moment will be equal to 5,000 times east distance plus 30,000 times east distance. There will get a total of a clockwise moment. So clockwise moment equals to 5,000 times the distance of 5,000 is 0.5 meter plus 1.5, they'll get 2 meter, so times 2 meter plus 30,000 Newton times this distance. The distance of 30,000 Newton is 1.5 meter, so times 1.5 meter. This will be equal to anti-clockwise moment. The anti-clockwise moment is y times its perpendicular distance, y times perpendicular distance, which is 4 meter. So y times 4 meter. So once you multiply here and here, and then you add of 55,000 Newton meter, this will be equals to y times 4 meter. So 4 meter, therefore y will be equals to 55,000 Newton meter, and then you divide by 4 meter. So once you divide here, you get y equals to 13,750 Newton. So this will be the thrust at point B. The thrust at point B. Now, one of the conditions for a system to be in equilibrium, the total of clockwise moment should be equal to the total of upward forces. Total of upward forces should be equal to the total of downward forces. For the system to be in equilibrium, the total of upward forces should be equal to the total of downward forces. It means when you add x and y, the summation should be equal to the summation of 30,000 plus 5,000. So when you take x plus y, it should be equals to 30,000 Newton plus 5,000 Newton. So x plus y, the value of y, we have got it here. So it is 13,750 Newton this should be equal to 35 Newton. So X will be equals to 35,000 Newton minus 13,750 Newton. Once you subtract here, you will get 21,250 Newton. So this will be the thrust at point A. So until here, we have got thrust at A equals to 21,250 Newton, and the thrust at B equals to 13,750 Newton. Once you add this, you will get a total of 35,000 Newton, which is a downward force, while these two are the upward forces. Thank you for watching.